Hello friends, what up? Do you know about airplanes? Today I am going to tell you about airplanes. Dude, keep subscribing to us. In an accelerated straight and level flight, an aircraft is subjected to 4 forces. Additional forces are involved in turning, diving, and rising flight. Lift is an upward acting force. Drag is a retarding force caused by the aircraft's resistance to lift and friction as it moves through the air. Weight is the downward influence of gravity on the aircraft. And thrust is the forward acting force generated by the propulsion system, or, in the case of unpowered aircraft, by using gravity to translate altitude into speed. Any object, including an airplane, is subject to drag and weight. An aircraft's lift and thrust are artificially manufactured characteristics that allow it to fly. To comprehend lift, you must first comprehend an airfoil, which is a structure designed to obtain reaction on its surface from the air it travels through. Early airfoils were usually just a gently curved upper surface and a flat undersurface. Airfoils have evolved over time to satisfy changing requirements. Airfoils had a rounded upper surface by the 1920s, with the greatest height reaching in the first third of the chord width. The thickest component of the airfoil gradually shifted backward as both upper and lower surfaces bent to a greater or lesser degree over time. As airspeeds increased, it became necessary to achieve a highly smooth passage of air over the surface, which was accomplished in the wing's airfoil derives a reaction beneficial for flight from the air passing over its surface by moving forward in the air. The wing's airfoil creates the most lift in flight, but propellers, tail surfaces, and the fuselage also operate as airfoils and generate variable amounts of lift. The Swiss mathematician Daniel Bernoulli discovered in the 18th century that increasing the velocity of air at a specific point on an airfoil reduces the pressure of the air. The airflow over the wing's curved top surface moves quicker than the airflow over the bottom surface, lowering the pressure on top. The wing is lifted up to the lower pressure by the higher pressure from below. Weight is a force that works in the opposite direction of lift. As a result, designers strive to make the aircraft as light as feasible. Because all aircraft designs have a tendency to gain weight during development, current aerospace engineering staffs have professionals in the field of weight control from the start of the design process. Pilots must also keep track of the overall weight that an aircraft is allowed to carry, passengers, fuel, and freight, both in terms of quantity and location. The distribution of weight, that is, the management of the aircraft's center of gravity, is just as significant in terms of aerodynamics as the amount of weight carried. Drag, which has 2 components, acts as a constant counterforce to thrust. Form resistance, owing to shape, skin friction, interference, and any other non-lifting components cause parasitic drag. Induced drag is created as a result of the formation of lift. As airspeed climbs, parasitic drag rises with it. For most flights, it is preferable to have as little drag as possible, hence great emphasis is placed on simplifying the aircraft's form by removing as much drag-inducing structure as feasible. For example, enclosing the cockpit with a canopy, retracting the landing gear, using flush riveting, and painting and polishing surfaces. The location and area of the fuselage, wing, engine, and impeded surfaces. The intersection of wings and tail surfaces. The unintentional leakage of air through the structure. The use of excess air for cooling, and the use of individual shapes that cause local airflow separation are some of the less obvious elements of drag.